Okay, in this example, we have a motorcycle starting from rest. It has an acceleration of, let's look that up because it didn't copy. It has an acceleration of 2.6 meters per second squared, I hat. After the motorcycle has traveled a distance of 120.0 meters, it slows down with an acceleration of negative 1.5 meters per second squared, I hat, until its velocity is 12 meters per second, I hat. What is the total displacement of the motorcycle? Okay, so I'm going to have to go back and forth to get those numbers that didn't copy over. Okay, so first thing I'm going to do is I'm going to go ahead and write my information in my boxes. I have DI, D final, VI, V final, A, and T. I want the total displacement. I'm going to assume that I start at 0 meters, question mark there. I have, it's starting from rest, so that's 0 meters per second I hat. I don't know. Yep, I get a final velocity, so let's see what that is. A final velocity of, right here, 12 meters per second I hat. So that's 12, was it 12.0? 12 meters per second I hat. My acceleration, let's see. Acceleration, negative 1.5. Negative 1.5 meters per second squared I hat. I'm not given time. Now, you may be saying, Dr. H, whoa, wait a minute. It says that it travels a distance of 120.0 meters. You're right. So here, you could put that number in here. Or you can figure out how far it goes to slow down and then add that to the 120. So I think that the easiest thing for us to do is to just put the 120 in to start with. And that's the beauty of this, is that you can always go back and change your numbers, right? So here you go. I'm going to erase that. And now I'm going to write in my 120. Oops, 120.0. Let me fix this. Okay, 120.0 meters I hat. Okay, so now I'm going to draw my motion diagram. I know that I'm traveling at a constant velocity. And then what I'm going to do is I'm just going to click on this. Let's see. Wait a minute. Why is it doing that? I'm supposed to be an arrow. There we go. And then I'm just going to paste there. Okay. Sorry, you can't do that. You have to draw them out. Now remember, you're going to be using your ruler to draw these. Make sure they're the same length for every time interval. Okay, so at first we're traveling at we've traveled some distance. Okay, starts from rest and has acceleration. After it has traveled 120 meters, it slows down with a new acceleration. Okay, so now we want to know, actually these speed up. So we're going to make them longer by the same amount. There we go. Sorry, it says it's accelerating from rest. Okay, now that it's accelerated from rest, we need to put our acceleration vector. Let's make that purple. There we go. Then what happens is it starts to slow down. So now they get smaller. We're going to make them red. And now we have a purple vector that goes in the opposite direction because we're slowing down. Oops. Let me see here. Yep, let's make that purple. Okay, so let's go ahead and label these. This is velocity, this is acceleration, acceleration, and now I've got to change the color of those. There. Sorry, I'm just going to color over them in purple. It's just easier to have your colored pencils out when you do these. Okay, so I'm looking at the problem and I see that I have no time. So I'm going to go to my trusty equation card. I'm going to go down the T column here until I see an X right here, and this is the equation I'm going to use. Okay, so let's go back to the problem. Okay. And so I'm going to go ahead and write that out. I have V final squared minus V initial squared is equal to 2A delta D. Okay, so I'm going to go ahead and solve for delta D. Delta D is going to be equal to V final squared minus V initial squared all over 2A. Substituting in our numbers, V final is 12 meters per second I hat quantity squared minus the initial velocity, which was 0, and we're going to divide that by 2 times the acceleration, which is negative 1.5 meters per second squared I hat. Okay, so we see here that we have meters squared per second squared. I'm just going to write everything out. Okay, so we end up with delta D or delta S or delta X, whatever you want to use is fine. Okay, so I'm going to go ahead and put my numbers in. I get 12 squared, and that gives me 144, and I'm going to divide that by 2 times negative 1.5. And that gives me a total displacement of negative 48. Okay, so if we take delta D is equal to D final minus D initial and set that equal to negative 48 meters I hat, we can figure out our final position, because the final position is equal to the negative 48 meters I hat plus the 120.0 meters I hat. So D final is equal to, so negative 48 plus 120 gives me 72 meters I hat. So this is my final position. How far did it go? It only went 72 meters. Okay, so that's how you solve that problem. Now, at first you may think, well, wait a minute, negative 48, that doesn't make sense. But that's just the displacement during the time when it's slowing down. Okay, so it actually slowed down, stops, and goes back in the opposite direction. But it had already gone 120 meters. So this just tells us that the final position is 72 meters. Okay, if you have any questions about this, mark it in your book or mark it in your lecture notes and make sure you ask me next class. Okay, we're going to go ahead and end this video, and the next video will be in the next example problem.